as we're considering aquatic and terrestrial pollution, we have to think about this concept of a range of tolerance. And different types of organisms can tolerate different levels of harmful substances in their environment, these pollutants that we're going to be talking about. And when these pollutants build up to levels that are outside of an organism's range of tolerance, they can result in a series of effects on those living things. If conditions are slightly beyond the range of tolerance, then it can lead to just general physiological stress to the organism. It can lead to lower levels of growth, slower growth, less reproduction or no reproduction, and eventually, if conditions get pushed beyond what the organism can tolerate, can lead to the death of the organism. Okay. And so the amounts of these pollutants that are being released into environments is really important, and the effects will vary from organism to organism. So we're going to talk about many different types of pollutants and their effects on ecosystems. Coral reefs are a biome, a marine biome, that is one of the Earth's most biodiverse ecosystems. And coral reefs are in serious danger from several impacts. One is ocean warming. We know that as our climate changes due to human-induced climate change, these coral organisms often are unable to tolerate these warmer marine conditions. And when coral organisms are stressed, what happens is coral is really a symbiotic relationship between an algae and an animal. And the algae live within the cells of the coral animal, and those algae, through the process of photosynthesis, they provide nutrition for the coral, and the coral serves as a home for these algae, so they have this symbiotic relationship. When the coral are stressed, the algae then, if they are stressed, can actually leave the coral's tissue, and that robs the coral of those nutrients the algae were producing, causing the coral to what we call bleach. It turns white when the algae are all gone. When the algae have abandoned the coral animal, it becomes this whitish color as you see here, and eventually that leads to the death of the coral. And so increased ocean temperatures are causing the stress on the coral reefs. The acidification of the ocean, as carbon dioxide levels in the atmosphere increase, some of that carbon dissolves into the marine ecosystems, causing them to become more acidic. That stresses these organisms as well. Sediment runoff from terrestrial ecosystems can be another impact, okay? And also physical destruction due to different types of fishing practices, such as bottom trawling, things like that, can physically damage the coral. And when these coral reefs are damaged, when they're bleached, this impacts the wide biodiversity that are typically present in these coral reefs. Oil spills can have a serious impact on marine ecosystems as well. An oil spill is basically the release of liquid petroleum, crude oil, into marine environments. And these oil spills can happen in various ways. Sometimes it comes from a tanker accident. Petroleum is transported around the world in the oceans on huge super tankers, which carry billions of gallons of oil. And if these tankers have an accident, then that can release large amounts of this petroleum into the water. Okay. There's a graph here that shows some of the largest oil spills that have happened in the world. So you can see here during the Gulf War, the Iraq Army released oil, 240 million gallons. The Deepwater Horizon happened in the Gulf of Mexico when there was a breach in an offshore oil rig, which led that oil pump to spill crude oil into the Gulf of Mexico for a very long period of time. And then there's a whole bunch of other accidents that you can see listed here. And one of the challenges for these oil spills is that The oil is less dense than the water. It floats on the surface, and therefore it can coat fur of animals and the feathers of various ocean-going birds. Organisms can ingest that oil, and it's toxic to them. Other components in these oil spills sink to the bottom, and they harm bottom-dwelling organisms. And this leads to wide-scale impacts to ecosystems because some of these oil spills are such a large scale. It can have effects on fishing, tourism, economic impacts as well. When these spills do happen, there's a variety of ways that people try to remediate or clean them. For large animals, often they just have to be cleaned by hand. You can see some workers here, using soaps. Even Dove soap can be used to take some of the oil off of the feathers of these organisms. You can use booms. Booms are sort of floating buoys which are spread around the oil spill, as we see here. And that tries to contain the oil so that it doesn't continue spreading. And after you've contained that oil, you can either vacuum up the oil, skim it off of the top, use different types of absorbent materials to withdraw some of that oil. Certain types of chemicals can be put on it to disperse it and break it down into smaller, less dangerous droplets. And there are even genetically engineered bacteria that have been developed that can be released to help break down some of this crude oil after a spill. And here you can see oftentimes these spills, even if they happen in the open ocean, they often wash up on shore where they can damage many of the organisms that dwell on the shoreline. You can see some people working here to clean up an oil spill on the shore. Another type of pollutant that we've mentioned before are pollutants which are called oxygen-demanding waste. These are typically nutrient pollutants, or sewage, for example, is an oxygen-demanding waste. These are pollutants that increase the growth of algae and eventually the decomposition of those algae. Those algae blooms leads to the expansion of these decomposing bacteria, which can use all of the oxygen that's in the water. And so as these organisms grow, decomposing these algae blooms or other materials, that robs the water of its oxygen, harming aquatic animals that require that oxygen. The term we use for this to quantify how much of this waste is in a body of water, we call it BOD, biochemical oxygen demand. And if there's high biochemical oxygen demand in a given aquatic ecosystem, that means is there's more organisms that are demanding oxygen from that water, and therefore as they consume that oxygen, they can make conditions anoxic, meaning a lack of oxygen, or hypoxic, which means low oxygen conditions, and that can eventually create dead zones. We can see, the Gulf, we've talked about this before, the Gulf of Mexico dead zone is caused because of all of this oxygen-demanding waste that ends up in the Mississippi River and is discharged into the Gulf of Mexico. And yes, I'm going to continue calling it that. That leads to a growth in these algae and subsequent decomposition, leading to these dead zones. Here we can see the Gulf of Mexico dead zone. These oxygen-demanding wastes create something that we call an oxygen sag curve. An oxygen sag curve is basically a graph that allows us to show how this oxygen-demanding pollution is affecting an ecosystem. And there's a couple lines that are typically shown on an oxygen sag curve. There's the dissolved oxygen level, and then there is the biochemical oxygen demand, the BOD. So here we see a general graph. So here we see this dotted line represents the original oxygen levels in this body of water. And we have the blue line is biochemical oxygen demand. And then the red line is dissolved oxygen. And so if there's a point source of oxygen demanding waste here, and the x-axis is typically the distance from the source of pollution. Around the area where this waste is being discharged, it could be sewage, it could be fertilizer. There's a high level of biochemical oxygen demand, and therefore a rapid decrease in oxygen levels. As we get further away from the source of those pollutions, this effect gets sort of diluted, and dissolved oxygen levels start to increase. BOD starts to decrease until eventually you get far enough from the source of pollution where conditions have rebounded to the original dissolved oxygen level. Here we sort of see a more visual depiction here. We have a point source of pollution here. Prior to that pollution, this is upstream. We have the clean zone where lots of different organisms can live. We have high levels of dissolved oxygen, low levels of BOD. But as this waste material is released into the water, the BOD increases rapidly. Therefore, oxygen sags and goes much lower, and that leads to the death of lots of organisms. Cannot tolerate those low oxygen conditions. However, as we get farther away from that point source of pollution, conditions can rebound. So this is called the oxygen sag curve. Heavy metals can also be dangerous. We've talked about some of these. Lead, arsenic, mercury are examples of heavy metals. These heavy metals are typically toxic to all organisms. And there's a whole host of them. You can see, some of the different heavy metal pollutants and what some of their impacts are on this diagram on the lower right. But they all have negative consequences for living organisms. Lead is dangerous, especially for young people, kids, infants. Oftentimes lead is introduced into people through water pipes. Old water pipes, sometimes they were made of lead or used a lead solder to join them together. And if that lead leaches out into drinking water and people consume that water, it can have negative effects, especially neurologically. Exposure in fetus and infants and children can lead to developmental delays and many other health problems. And we'll spend some more time thinking about Flint, Michigan, where a change in the source of water to the city of Flint resulted in lead leaching into the water supply and exposing tens of thousands of children to high levels of lead. Arsenic is another heavy metal. It can lead to cancer. Arsenic is found in the environment oftentimes due to mining activities because of acid mine drainage, which mobilizes arsenic, or industries which use arsenic or have arsenic as a byproduct of their manufacturing, and improper disposal of that waste can lead to the arsenic being released into water or onto land. Another example is mercury. Mercury can be released from burning of coal, and it's about 2/3 of the mercury that gets released in the atmosphere comes from the burning of coal. It can come from other sources as well, such as manufacturing. And mercury is toxic. It can lead to various types of central nervous system disease, especially for young children. And mercury in its elemental form, its inorganic form, is actually not toxic. But oftentimes what can happen is that elemental mercury, Hg, inorganic mercury, in certain types of soil and water, there are bacteria that transform that elemental mercury into a form that's called methyl mercury. Methyl mercury is extremely toxic. And so when that happens, that process happens, that can lead to the formation of this toxic methyl mercury. There are certain types of bacteria that can undo that process, taking methyl mercury, a toxic form, and transforming it into a less harmful form, which is elemental mercury. Mercury is also one of those heavy metal pollutants that can build up in aquatic ecosystems through bioaccumulation and biomagnification, so that seafood can have high levels of mercury in it especially seafood that's high in the trophic levels. And again, we see in these diagrams a few different depictions of this. We can see, the heavy metals that are in the oceans, aquatic ecosystems are shown here on the right. And also we see sort of how some of these heavy metals enter aquatic ecosystems through runoff and in sediment. We can see some of those shown here. And there's also the transformation of them by various organisms in aquatic and terrestrial ecosystems. Plastics can be damaging to ecosystems as well. We probably all have heard of choking of aquatic animals, marine animals on plastics, microplastics in our environment. Plastics are materials, they're petroleum-based products that take very, very long to break down and often don't break down at all. We can see this graph shows about how long typical marine debris takes to decompose or break down. So fishing lines, 600 years, plastic bottles, 450 years, etc. And so we can see that these things, once they're littered in our oceans, they can last there for very long periods of time. Oftentimes, ocean currents concentrate them in certain areas. We can see some of that here. You may have heard of the Great Pacific Garbage Patch, an area in the ocean where ocean currents concentrate lots of these plastics. There are also microplastics, tiny little pieces of plastics that are used in all sorts of products that we consume. They also can have impacts on health and on organisms. Sediment can also be an aquatic pollutant. When sediment runs off into the water, it can increase the turbidity of the water. It means it can reduce its clarity. It can make it more cloudy. And increasing the turbidity of the water reduces how much light can get through the water for producers. Sediments can clog up the gills of animals that get oxygen from the water through their gills. As it settles, it could damage ocean bottom ecosystems as well. And a lot of this sediment runoff comes from agriculture through improper use of various agricultural techniques that can lead to the erosion of soil, deforestation. Remember, the roots of those trees no longer anchoring soil can lead to increased levels of erosion, as well as construction near bodies of water. All of those things can increase the sedimentation, which leads to these issues. And the last part of this topic, which may seem never-ending, is about the various types of federal legislation that are used to try to control aquatic and terrestrial pollution. So we'll talk about a few pieces of legislation here. The first one is CERCLA. CERCLA stands for the Comprehensive Environmental Response, Compensation, and Liability Act. This is typically called the Superfund Law. And the Superfund Law was passed in 1980. It's administered by the Environmental Protection Agency, the EPA. Excuse me. And the Superfund Law, CERCLA, what it does is that's not what I wanted to do. What it does is it tries to identify, investigate, and clean up sites that are contaminated by hazardous waste, hazardous substances. There are about 40,000 federal sites in the United States that are listed under the CERCLA law, that are listed properties, listed sites of contamination. And what the CERCLA law does is it tries to identify whoever in the history of that site, whoever is responsible for the pollution, the toxic pollution that needs to be cleaned up. And the law is meant to make the polluter pay. So as a part of the CERCLA process, a responsible party is identified, and they are assessed the fee to help pay for 70% of the cleanup of that area. So we can see here on the bottom, this sort of shows this diagram, how the CERCLA law is enacted. And so once contamination has been discovered, the site is assessed and inspected. If it's found to be heavily polluted, it's then placed on what's called the NPL, the National Priority List. And then studies are done to figure out how best to clean up the site. A plan is put into place, a decision is made, and then the site is cleaned up, ideally with the potentially responsible party paying for the majority of the cost of the cleanup and repurposing of that site. And eventually, after the site has been cleaned up and remediated, it can be taken off the NPL list. And here you see a map that shows some of the CERCLA Superfund sites. We'll do an activity in which you're going to find if there are any near us. Spoiler alert, there are. And the CERCLA Act was passed as a response to several prominent instances in which people really suffered serious health consequences due to toxic waste being disposed of in improper ways. One of those is in New York State. It was called the Love Canal disaster. Okay, and the Love Canal disaster happened in Niagara Falls, New York, where there was a canal that was dug. It was only extended for 1 mile, then shut down. But then this property was given over to a chemical company, Chemical Company, which basically disposed of their toxic materials from their manufacturing in this canal, and eventually they turned it into a landfill for this these toxic barrels of substances that they put there, and they dumped these toxins there for decades. And eventually, as the town of Niagara Falls grew, the land was reclaimed by the town and schools were built there. At one point, there was some of these barrels collapsed and formed sort of an indentation in the ground that filled up with water that kids would actually play in. And this was filled with these barrels of toxic waste. And so the site was cleaned up over a period of 20 years through this process of the Superfund process. Another piece of legislation, federal legislation, is the Clean Water Act, also administered by the EPA. This was passed in 1972 at the time when lots of environmental regulation was being passed. And the Clean Water Act, it doesn't address groundwater contamination, but it does address what the law says. Its purpose is to restore and maintain the chemical, physical, and biological integrity of the nation's surface waters, basically streams, rivers, lakes, ponds. And the Clean Water Act funds wastewater treatment. It funds the maintenance of wetlands. And what it does is it requires any facility that's going to be discharging water or discharging waste into a body of water to require a permit. And it sets standards as to what can be in that water, and it sets water quality standards. So we can see this diagram on the right. This model shows sort of how this process takes place. So the Clean Water Act defines certain standards which water has to meet. It monitors and assesses those waters. If there are any potential impacts to those waters that could push them beyond water quality standards, then they are addressed through federal agencies. Okay. It requires point sources, I said, to get permits and to disclose and allow for testing of the waste that they're discharging. And it tries to also manage non-point sources as well, which are much more difficult. And so if we look at, who is releasing waste into the waters, this graph shows Clean Water Act permits in 2011 to 2015. Some of it's through transportation, mining and drilling is a smaller amount, and agriculture, etc. You can see sort of where these permits are going. And finally, we have the SDWA, the Safe Drinking Water Act. This was passed in 1974. Safe Drinking Water Act oversees states and municipal water systems, and they are responsible for implementing the standards on the Safe Drinking Water Act. It regulates, there's over 150,000 public water systems throughout the country, and it sets standards for drinking water. Right, there's standards for how much of different types of microbes can be there, such as coliform bacteria or giardia, disinfectants like chlorine and other byproducts. It sets standards for how much arsenic and copper and lead and other potentially dangerous materials can be in drinking water. And the Safe Drinking Water Act also is responsible for regulating the amount of lead in drinking water. And so to maintain the quality of drinking water, the first step is in protecting the source of that water. Different areas of the country get water from various sources. It could be surface water, it could be groundwater, aquifers, etc. That water can be treated to make sure it meets the standards of the Safe Drinking Water Act, and it has to be monitored, and municipal source of water have to monitor and then report to their customers the quality of the water that they are consuming. And we'll look at some of those reports in class.